system of linear inequalities, right? These work in a very similar way to what systems of equations did, right? So this is made up of two or more linear inequalities. All right, so what we talked about graphing yesterday, we're talking about graphing two or more of those. And the solution is an ordered pair that makes all of the inequalities true. Okay. So remember yesterday we talked about this. When I go to graph these, all right, I'm graphing just like I graph a line. So if I look at y is less than 2x minus 3, where am I going to start when I go to graph that? Negative 3. All right, make a point there. Dig and dodge, what's my slope?
Slope?
Yep.
2.
2. So I'm going to go up 2 over 1. Okay. And
what did you say? An ordered pair that makes all the ordered pairs true?
Isn't it inequalities?
yeah, it should be inequalities.
Okay.
All right, this up here, sorry,
That's like,
should be inequalities. I wasn't paying attention. All right, so now here's where things get a little different, right? Normally, remember we just connect the dots and be good to go. Now I have to decide, do I have a dashed line or a solid line? So, anybody remember yesterday what kind of line I'm going to have if I have less than or greater than?
that.
Dashed, right?
Because
Oh,
of the
yeah.
line.
Because if it's not equal to, I just have a dashed line, right? And then I needed to do that whole test point deal, right? So what was the test point we talked about almost always trying to use? 0, 0. Does that work for this line? Why?
It doesn't go through 0.
It doesn't go through 0, 0. So I'm going to plug that in and say, is 0 less than 2 times 0 minus 3? Or is 0 less than negative 3?
Yep. No. Yep, no.
So is 0 less than negative 3? No, right? Negative 3 is smaller. So now when I decide to shade, where am I going to shade? Area 1 or area 2? 2. All right, so I'm going to shade all of that down here. And so now when I get to doing the system part, right, now I just have 2. So I'm just going to graph the next line on this same graph. So I kind of have standard form-ish looking there, right? So we talked about 2 ways to do standard form. One of the ways is to solve for y. So how could I get y alone here? I could subtract 2x from both sides. All right, so I have y is greater than negative 2x plus 2. So now I look and I say, what is my y-intercept? 2. And my slope is negative 2. So I'm going to go down 2 over 1. And then again I ask myself, is solid or dashed? Dash, right? So I have greater than. So I'm going to make a dashed line. And can I use 0, 0 as a test point still? Yes, because that line doesn't go through it. Here's where you want to go back to your original equation. All right, so 2 times 0 plus 0 is greater than 2. All right, so that gives me 0. It's greater than 2. Is that true? No. So where should I shade? 1 or 2? 2. So now if you notice, right, now I've got your paper, it's just going to look like where you have more shading, right? But if you look up there, you can kind of see the red and the blue. And so the solution to this is where the red and the blue are intersecting, right? Where they're both being shaded. So this area here, right, is where they intersect. That's the solution area. So one thing just to keep in mind is like on a multiple choice question, like on the exam and stuff, if it's a multiple choice and you have to pick which graph, a lot of the times it's going to show these two lines, but it's only going to go show this area shaded, right? They won't shade up here and they won't shade down here. Just know that. All right. I don't care if you shade everywhere. That's fine. Okay. Questions on that one?
Yeah.
Yes, Cora.
For that red one, you said no, but it's greater than negative 3.
0 is not less than negative 3, though. Right? Because is 0 less than negative 3?
No.
No.
No. So that's why it's a no, and I shaded where 0, 0 wasn't.
Okay.
Just take poster color.
They painted. So y is less than 2x plus 4. So, Hayden, where do I start? Where do I start at y is less than 2x plus 4?
4.
4. All right, so I make a point there at 4. Michael, what's my slope there? 2. So I'm going to go up 2 and over 1. I want to do my test point. Does 0, 0 work? Yes, because it's not through the line. So I plug that in and say, is 0 less than 2 times 0 plus 4? And so I have, is 0 less than 4? Yes. And then back one step, because I forgot. Should I have a solid or dashed line here?
Yeah.
Dashed. All right, so now I look, I had a true inequality for 0, 0, so should I shade in 1 or 2? 2, right? I should shade where 0, 0 is because that was true. So I'm going to shade down here. Okay. So I'm going to take a minute and talk about graphing standard form if you don't solve for y. So this one, you could solve for y. It would be a little messy. So the other way we talked about is how you could find the intercepts. So if I think about this as an equation of a line I'm going to graph, when we talked about finding the x-intercept, right, what was the value for y? 0. So I plug in 0 for y, so I'd have negative 3x equals 6. So what is x going to equal? Negative 2. So what I'm going to do is I'm going to go make a point at that intercept. So at x equals negative 2, I'm going to make a point. And then when I want to find the y-intercept, what's the value of x? 0. So I plug that in and I'd get negative 2y equals 6. So what would y equal? Negative 3. All right, so I go down to y is negative 3, and I make a point. And so then I look at it and I go back up here and say solid or dashed line. Solid, because I have the or equal to. So that solid line. And I go back to do that test point. So 0, 0. That work? Yep. So I go to my original equation and say negative 3 times 0 minus 2 times 0. So it gives me, is 0 greater than or equal to 6? No. All right, so I'm going to shade where 0, 0 isn't. I'm going to shade down here, which means that solution is kind of there, right, where those two things overlap.